Before I start the video, I would like to say thank you to PLCNEXT Japan that borrowed the CPU and module to me to create this video. PLCNEXT Japan, thank you.
Hey, hello everyone, I'm Please. In this video, I will show you a module that comes from PLCNEXT. The release, I think, is 2022 summer. XCF-XTML1000. This is a module for machine learning, and I hope you like my video. Let's start.
Hey, hello, here is the hardware that I'm using this part. In the left hand side is the main character of this video. It is the module called XCF-XTML1000. ML is mean machine learning. Reference the menu inside this module that says TPU. TPU inside was so it means that you can use the TensorFlow model inside your application and run your machine learning program. So if you read my other post before that, you know that I also have a project that is use TPU, but not this module. It's a USB type. They connect to a Raspberry Pi and play with Trinket. If I've also put this link in the end of my video, then you can take a look of this. Okay, so when you use this module, there's a 2 points that I would like to tell you need to take care. The first point is the CPU type. What do they mean? If you want to use ML1000, you also have a CPU with V152, a higher model of PLCNEXT CPU. So if you only have 152 or 2.52, sorry, you cannot use this module. The second one is the power source problem. Okay, when you see the wiring here, the module power is connected here to the connector of CPU and then connect to the terminal. What does it mean? It means they are using the same power source. It's also reference to a manual that if you don't use the same power source, they'll have some problem. If you only have power in this module but don't have power in your main CPU, then your module turn to error status and can reset. Although even you turn on the power on CPU of the CPU in this time, your module still cannot reset. Maybe the module will be in a string condition, so it's also a point that you need to take care about this. Okay, here is my simple introduction. In the next part, I'll show you how to configure it, and see you next part. Hey, in this part, I'll show you how to set up the ML1000 module. Let's start. Now you can see this is my screen that the power is turned on my CPU. But reference to the menu, actually this LED should be turned on to green, but I don't doesn't turn on. Actually, it's working now. So now the power is turned on. That's okay. Now you need to set up your ML1000. But before you set up ML1000, there's a two conditions that you need to confirm that you get. The first one, you need to have the root account. Why? You need to because you need to transfer some file by using root account from your OS on your PC to the user lib directory. In case that the system will ask you a root account. The second one is you need the internet connections. Why? Because you need these internet connections to get the project from the Github and install some package if you want. If you have these two conditions, you can continue. Okay, so before we install this we set up this module, that is a two software that I would like you to install in your OS first. The first one is this PuTTY. It is a SSH client that for you to extract the PLCNEXT CPU by using some command lines. It's very convenient. It should install it or just any other software that with SSH client. The second one is the WinSCP. It is a software that allow you to use your computer as a SFTP client and then to download or upload the file to a SFTP server. Why you need software? Because inside the PLCNEXT, for example, in this case is 3152, it have a SFTP server inside. So you need this software to create a client to download or upload to make some file operation inside the CPU. Okay, so I hope you install this software. The first part you need to do is you go to the PLCNEXT contact page of the ML1000 module, then go to downloads, package zip, and the software, and download this ML1000 underscore package.zip. So what's this? It is a file that when you download this file, just wait a second, and here is the files inside one M1000 package. You have a .so1, two .so1 file, and one proto file folder. This one you use later, but now we'll use these two file now. And okay, so open your SFTP client software, and then go to the login next root account, and go to the user lib, where's lib? Yeah, lib, and drop this to file to download to your SFTP server. And that time the system will ask you, could you give me your root account something. So please make sure that you have the root account. Okay, so after you download these two files inside your SFTP, it's maybe better to restart the power and then go to property. Oops, not this one. Go to property. Yes, here. And enter this command. So I also paste this command in the video description. So don't worry. If you after you execute this command, if you see some message like that, it means congratulations, the PLCNEXT can see your ML1000 modules. Then you can now ready to configure to use it. If you see any error message in here, it means so many cases. For example, it means that your installation is not properly. If you don't have power, or you are not using 3152 CPU. Yeah, so please make sure this case. Okay, so after that, then the second step that you need to install the Python basic from PLCNEXT App Store. Don't go to here. I also will paste this thing in my description of my videos. Here is the Python basic. You can install it offline. Don't worry, I also have a tutorial that how to install the offline apps in your PC, from your PC to the PLCNEXT. Don't worry. Inside this package, you can find so many, or the machine learning package that you need, at least you need in the applications. You can also install it one by one, but I don't prefer that. It's not very efficiency, and you make some trouble sometime. So it's will install this Python basic package into your PC, from your PC to PLCNEXT, and then after that you can do the first step. Now you can use these two commands to clone the example from Github to the PLCNEXT CPU. I'll explain this commands one by one, don't worry. Okay, so let me browse inside. I think my directory is user, is home and root. Yeah, here. So the first command is make direct cromla and cd cromla. So it means I will okay, yes, here, and it means that I will make a folder called colon and browse inside and change the directory inside. So now after you execute this command, your working directory will change to here. And then the second command git clone this address. It means to clone the project from GitHub to your PLCNEXT. And then finally, you flash example classic image in OTA. So browse inside, go to example, you execute this .sh cell file to install all the package that you need. Very good. Okay, so after install all the package, then now you can check your installation is properly work or not. How to check it? Here is the command. I will copy it and then open putty, paste it. Good. If you see the result like this, it present time, and then to show the first time is a little bit slow. It's 26.4 milliseconds, and 4.2 milliseconds, 4 milliseconds, and show the result is it burst something. Bingo. Then it means your installation is finished. I'll explain a little bit more about this command or what is this stuff is working. I will open the script of this classic image.py. So where is this? It's inside examples. This one, classic image. Open it. Okay, so let me open the command. The first line is in here. You can see there's some arguments is required. The first one is the model and input and labels, and other one is optional. Okay, so the first one is the model. Model is here. Let's need to pass the .f.40. It is the model file of the TPU as the first parameters. The second one is the label. Label is just a text file to have so many terms. What, for example, number 1 is 1, number 2 is what something. So here also it's true. Need to put inside. Then the second one is the label. No, sorry, the label. Yeah. The third one is the tested data. So what is the tested data? The tested data is the image that you want to classify. It makes sense, right? If you don't pass the image they want to classify, how then you classify? What do we want to do, right? It also makes sense. So here is what these 3 lines doing, and after that they read the label and then do the classification and output the result back to terminal. That's great. If this result, your part 1 is finished. So now, although we now know the result, but we also would like to transfer this result from your terminal, your applications to the PLCNEXT. You have so many methods. You can use OBC UA, you can use MQTT, or just Subcat. But I'll show you that there's a method they are using in this tutorial is gRPC. Just wait a second. Here. Yeah, here is the gRPC. Do you remember that when you download the ML package, there is a file called photo, right? So we need to use this folder to make some magic stuff. And okay, so let me make a very simple briefing for what is gRPC. So here is the page of gRPC. Here is the server and here's the client. Then you see the client and server are implemented by different program language. So it's not so you can only use Python. You can only use Java. No, it's not based on programs. You can program in any language. Then they have tubes to generate the parts of code automatically. Then you only need to send the request, and the server will give you the response. And good thanks for PLCNEXT. The CPU is this RPC server is integrated inside. So it's not. Does that mean in here it is images? This RPC server is your PLCNEXT CPU. In this case, 3152. And here the client is your application. Is your Python script. Okay. So what you need to do in here? You need to use put this file folder pro2 to the directory that
your script that you execute. In here is home root color color pie color example. I'll execute the script here, so I need to put the file, this Pro2 folder inside here. And then you also need to extend your script. I will also show you how to extend it. And don't worry, in my tutorial I have a full code for this extension. Don't worry. Open this classic images PLCNEXT. Here, the first very similar. The first one here is to import the necessary module in here, and then open the security channel, and then finally, after you classic the image, not just print it out in terminal, but transfer it also to this main1.int_1, and this request is doing by these functions. In this function is also defined from here. It's just now you don't need to know what is it doing, but I'll explain. This port name is the variable name, and the pstring value is what value that you want to write. Then you need to exit the channel, and then create a request, and then set up your variable name. Here is port name. Type 1990 is stringed, and then the value, and then write the request, and then return the response. Very easy. Okay, so now I'll execute the script and see what happened. Okay, so before that, we open my PLCNEXT, and then here is INTA. Have some value in here. I will just return it to empty. Okay, just wait a second. Okay, now it's empty, right? I'll execute the script again. I think it's here. Just wait a second. Next to py. Okay, I think this one. Okay, well, if I execute it, you see the value is also written, not just over to the terminal, but also over to the variables inside your PLCNEXT engineer. It's really the over the value to your PLC applications. Okay, congratulations. If you can follow here, it means your installation is finished. You can make your machine learning applications, and also not just output the result in terminal, but also transfer your result from script to your PLC applications. Congratulations, you're doing very good job. In the next part, I will show you more fun things where you can integrate it with RoboDK and pay for some OBC UA or a bit more stuff. See you in the next part. Okay, now you configure your MR1000, and you can start your machine learning application, the result, and then also transfer the value of your inspection result from the application to PLC applications. In here, I will show you a little bit more interesting things. I will show you how to use RoboDK to integrate with the MR1000 modules to make some funny demo. In this part, you touch not just MR1000 but OBC UA and HMI something. First of all, we need to configure the OBC UA server in the PLCNEXT v152 site. Okay, go to your PLCNEXT project engineering tools. In here, the version that I'm using is 2022.6. You can not use the newest one, but I think at least you need to use 2022 point something. It should be better. Okay, next part, then open your project, go to OBC UA, and
first step, you need to check your server certificate is self signed by control is the most easy one for the login for you to log in the server. And the second thing you need to configure is the security policies. You need depends on your client. You need to choose which security policies are they able to use or not. And the third one I would like to show you is the base setting. In the base setting and the visible of variables. Yes, all, but it's up to you because now I just demo and then I know the security in here. If you can choose mark, so what to me is mark, go to your main program here. There are variables. In here is the OPC. If you choose mark, only the variables that with a check mark the client can access it. Yeah, it's just a check mark. No need to take care too much. And the second one, you need to configure a touch panel for just some display and for a start button. Go to the HTML web server and applications page. Here's a page that I create for display the status and make a start program. But this is my first time to use PLCNEXT to do the HTML page. Maybe I cannot make it very beautiful. If a start button and then have some result to return the data from the machine learning application. Oh my god, I made a mistake here. Just made a mistake. It's not 5, it's 0. Oh my god. To dynamic, I think it's dynamic. Here, yes. Go here and go here. It is 0. And also this one is also 0, not 5. Okay. Oh, here's finished. And then I'll show you the configuration now. Just a second. Here's configuration now I used in this demo. Here I used RoboDK. This is a offline program simulation software. It's free. It's allow you to run the robotics. I feel like this software actually. And inside this station I configure a robot and a camera. Yes, in all RoboDK also it can simulate a camera. Then you need to transfer the data and make some handshake between the RoboDK software to the OpenCUA server inside your v152. So in the data here is communicated by OpenCUA, and then in my demo I will transfer the image take from the robot, from the camera to the CPU. So I use SFTP also to transfer all my image that I took inside and send to send to v152 by using SFTP protocol. Then finally, as I mentioned before, the script is the inspection result and all handshake in the ML1000 that I'm using. I use gRPC to make a data exchange between my applications to PLC applications. It's very easy. And then I'll show you the program here. Here's the main. If you open my project, you can see a little bit variables is defined in here. So what is that? For example, this DUT is just a data unit type. For example, DUT ML1000, yes, it is a data type sheet that I define a couple data types to read or write the data between the ML1000 modules. And also this RoboDK is also the data that read or write between RoboDK and my PLC applications. And also typical. Now I'll show you the handshake between RoboDK, ML1000 and the CPU. Just wait a second. Here is a handshake diagram. First of all, the PLC v152 will send a start signal to RoboDK, and then RoboDK always wait this signal to start. And this is when true, you start to run the robot program and
take the busy thread to true and then send all the photo to the S3152 by using SFTP protocol. And then when all the program while the robot program finish, you send the end flag to the CPU, and the CPU will send the start apps equal to true to ML1000. And when ML1000 receives this signal, he'll start to make the classifications of the image that we receive from RoboDK, and then we transfer the result and also send the end flag to true while all the script is finished. The script is finished. And after that 315, the CPU no need this flag to be true anymore. You turn this flag to false. And when ML1000 receives this flag is equal to false, he will reset all its data and then send it back. And while V152 receives, oh, okay, you finish all your stuff, I can also call RoboDK to finish it. They send a can true equal to false signal to RoboDK, and then they'll end. Very easy. Actually, I think this could be difficult to show or to explain all the Python script between the ML1000 side and RoboDK side. So I will just show the result and how to start is something. Then you can follow my tutorial to get more information. Okay, very good. So here is my applications. Here is my machine learning application with Python, and here is my RoboDK workstation. Okay, so I will start to run the robot program by just open my files plus start program. Then all the data with all the inspection result will change back to 0. And then now here is taking the photo. Okay, after that you can now use SFTP client, then refresh it. Okay, this means some photo is received from RoboDK to your server to here. Then in the files, you can see all the result here also. Here is the application that what the demo I done to in here. So I hope you like this, and I think it's better that if you really like my video, I hope you can subscribe it and give me a like. I'll see you next time, and sorry for my English, because my English is really not very good. I need to do a little bit more in speaking. Okay, thank you, and I'll see you next time. Bye bye.